Now this question is a little bit different from the ones that we've talked about previously because it's telling me that in addition to having this, we've also thrown in a solution of calcium nitrate. Calcium nitrate is a very strong electrolyte, which means it dissociates completely and instantaneously to form 1 molar equivalent of calcium 2 plus and 2 molar equivalents of nitrate. It tells me that the solution that we're throwing in here is 0.01 molar. Now what that means then is because this is present in a 1-to-1 ratio relative to calcium, and I don't give a crap about the nitrate because the nitrate isn't a common ion up here. This is going to give off or spit out 0.01 molar equivalents of calcium 2 plus. So what that means then is that at initiation, so what we've typically done with these is we've written down 1 as being the initial concentration of calcium fluoride and 0 as being the initial concentrations of each of the ions to the left or to the right. However, that is not going to be the case here because I have a separate source of calcium 2 plus that instantly dissociates, so my initial concentration of calcium 2 plus is the same. So this is going to feed back up here into this reaction. So that is the difference here. Now as this reaches equilibrium, it's going to dissociate by a certain amount that I'll call X. The equilibrium concentration will then be reached by adding these two together. Over here, however, it's going to increase by an amount of plus X and plus 2X because there are 2 molar equivalents of fluoride to calcium fluoride. I add rows 1 and 2, I get 0.01 plus X is my equilibrium concentration of calcium. I get 2X is my equilibrium concentration of fluoride. Okay, so what I have to do then is take these values and throw them into the corresponding locations in the expression. Calcium 2 plus is equal to 0.01 plus X. Fluoride is going to be 2X, and I have to square that, and I set that equal to this number. Now here's a trick I've talked about elsewhere. 0.01 is going to be so much larger than X that I can pretty much just throw out this X and pretend it doesn't even exist to simplify the math, and for all intents and purposes that'll work just fine. So this simplifies then to be 0.02x squared being equal to this number 3.9 times 10 to the negative 11th. All I have to do now is solve for x. Now I did that earlier and I got x as being equal to 4.42 times 10 to the negative 5th. It's asking me what the molar solubility is of calcium fluoride, and because that value right there, x, is equal to x, that is the final answer to this question.